Okay, now we'll do question 4. It says use the unit circle to estimate sine 20. Notice these are in pairs, sine 20, sine 160. They go together because 160 and 20 make 180. 30 and 150 make 180. 50 and 130 make 180. They're all sine values. So we'll do them on the unit circle above here. So you can see the first one, it was 30 and 150. So here's 30 and here's 150. Now those two angles add up to be 180 degree. You can see they're kind of symmetrical. They both have the same y coordinate. Now if we were to get the sine value of this is the y coordinate, which is 0.5, corresponding to the y value. The sine value of 150 is 0.5, corresponding to the y value. So they're the same. Sine 30 equals sine 150. And you can do it with the other pairs as well. Like for example, if you had 50 and 130, here is 50 degree, here is the 130 degree. Both are adding up to 180, and you can see both have the same y coordinate, so they both have the same sine value. So if we come back and look at the question 4, you can see that sine 20, sine 160 will be the same, sine 30, sine 150 will be the same, sine 50, sine 130 would be the same. So if we put that as a general rule in question 5, when it says what do you notice about your answers in question 4, you can say that they're the same, providing the two angles out to 180, and you can write it like this: sine of 180 minus theta. Now notice 180 minus theta, let's look at this as an example. If you do 180 minus 20, then you'll get 160. Right, so since those two add up to 180, if you take one away from 180, you'll get the other answer. So we could say sine of 180 take theta is the same as sine of theta. For example, sine of 180 minus 20 is equal to the sine of 20. Because 180 take 20 is 160, and we know sine of 160 is the same as sine of 20. So that's a general rule that we can use. Sine of 180 take theta is sine of theta. Likewise, we could do it for cos. In 6, it's asking us to compare these two angles. Now, the two angles that add up to 180, we give that a name supplementary. So these pairs of angles are supplementary angles: 20 and 160, 30 and 150, 50 and 130. And it's going to ask us a rule for that. So let's look at the cos again. So let's do 30 and the supplementary angle 150, because they both add to 180. Now let's look at the cos value. The cos value is the x coordinate. You can see the x coordinate for this one, it looks like it's about 0.86, around to there. The x coordinate of this one, can you see it would be minus 0.86, which is up to there. So it's almost like whatever the one angle, you just put a negative and get the other angle. We could do another one like 50 and 130, both are supplementary angles. The x coordinate of the 50 is it's around about there, so it's about 0.65, and 130 it's minus 0.65. So as a general rule, we could then answer question 7 and say that cos of 180 minus theta is the negative of cos theta. As an example, what they're saying is cos of 180 minus 20 is the same as the negative of cos 20. Okay. Okay, now question 8 pulls all of that together. Yeah, we can see the unit circle on the right hand side. It's got 3 questions, A, B, C. See if you can read through that and do that yourself. So pause the video and come back, and then I'll give the answer. Okay, so part A is what is the measure of AOQ. AOQ, you say angles with 3 letters. It's A, O, Q, so it's the angle between those 3 points. And so this is the angle we're talking about here. This angle is that angle there. Notice we measure from the east line anti-clockwise. Now we know theta's sitting in there and theta's sitting in there. We know all the way over to here, over to the west line, would be 180. So if we go backwards, when we go clockwise, we subtract. So it's 180 minus theta. So this is really minus theta rotating clockwise. This is 180 minus theta rotating anti-clockwise from there all the way around to there. So that's the answer to A, 180 minus theta. Then part B, it wants you to say what the reflection is in. It's clearly in the y-axis. You reflect point P, it will become Q if you reflect it in the y-axis. And the coordinates of Q, well, we're going to have, if you reflect cos and sine in the y-axis, you're going to have minus cos, but you'll have the same positive sine, because they have the same y-coordinate, but the x-coordinate, instead of going to the right, is now going to the left. So it's minus cos, comma sine. And then it says now write Q in another format using part A. Well, because the angle is 180 minus theta, we could say then that the coordinate of Q is also cos of 180 minus theta, comma sine of 180 minus theta. Okay, so that's that point there. So we found 2 ways of doing it. That part A is saying that we could have that for the coordinate of Q. Part B is saying that we could have it as this for the coordinate of Q. And that agrees with what we found right up the top, that cos of 180 minus theta is equal to the negative of cos theta. That was the first rule we learnt. And sine of 180 minus theta equals sine of theta. That was the second rule that we learnt. Now we're going to look at the tan function. We won't do this section, I'll just, apart from just highlighting what tan is. It's written here that tan theta is sine theta on cos theta. That's the definition for tan theta. That actually is the slope. So it's the slope of the line, OP. And the reason it's the slope is because slope is rise on run. And you can see the sine theta is the y-coordinate, which is the same as saying the rise. And the x value, which is cos theta, is the run. So sine on cos is the same as saying y on x, which is the same as saying rise on run, which is the same as saying slope. So working out tan theta is working out the slope of the line, and you can use that in the calculator, the tan of an angle.